Hello friends, welcome to the Education Wave. In previous chapter, we learn about the what is the definition of thermodynamics, surroundings, types of systems, and types of walls of containers, thermodynamic parameters or variables, equation of thermodynamic states, and thermodynamic processes. In the thermodynamic processes, there are four types of thermodynamic processes. First one is isochoric process, isobaric process, isothermal process, and last one is the adiabatic process. Generally, we also find the work done in thermodynamic processes mathematically, which is equal to dW is equal to PdV. So these are the parameters we discussed in the previous lectures. So in this lecture we discuss about the isobaric process. So in the isobaric process the pressure remains constant. Mathematically we write that dW is equal to PdV. We find this relation in the previous lecture. So if we integrate both side from the limit v1 to v2 PdV, this will be equal to PV2 minus V1. So this is the expression for the isobaric process where the pressure remains constant. So another process is isothermal process. Which isothermal process? In the isothermal process, the temperature remains constant. So this is a very important process in the thermodynamic processes. In this isothermal process, temperature remains constant. So mathematically, we know that PV is equal to nRT. Okay, PV is equal to constant. Why? Because in the isothermal process temperature remains constant. So we write that P1 V1 is equal to P2 V2. Okay, as we know that dW is equal to PdV. dW is equal to RT upon V dV. Okay, how? We know that PV is equal to nRT. Here the n is 1, so if we calculate the P, which is equal to RT upon V. Okay, so in the next line we integrate, in the next step we integrating both side RT, integrating both side, which dV by V. Okay, from V1 to V2. So this will be equal to W. This one will be equal to W is equal to RT natural log of V from the limit V1 to V2. Okay, also we write that RT natural log V2 upon V1. If we remove this natural log, so this will be equal to 2.303. Okay, 303 log V2 upon V1. As we know that P1 V1 is equal to P2 V2, where V2 upon V1 is equal to P1 upon P2 So this will dw w is equal to 2.303 RT log P1 upon P2. Okay, so this is the last mathematical expression for the isothermal process where the temperature remains constant.